Dear students, today we are going to start discussing sequences. If you have learned sequence at the end of your calculus course, on who knows, maybe at the beginning, it depends on what type of calculus course you have taken. Those students who are here have learned it quite in the beginning. There could be others who have learned it quite towards the end. So, a sequence is a function from the set of natural numbers which consists of our positive numbers 1, 2, 3, 4, 5, 6, whatever, to Rn. So here we are matching each number of the natural number set to some vector in Rn. What we learnt in our childhood calculus courses, I would say, is a sequence in R. Of course, why he's talking about a sequence in Rn does not trivialize the study of sequence in R, because that is the base on which everything is set. An alternative way to write a sequence is xn, and for each n I have x1, x2, dot 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 dot, x1, x2, dot dot dot, x3, dot dot, x4, and so on. There has been several misconceptions about this way of representing a sequence in this bracket and putting xn, where n is varying over capital N, which is understood. Now, many people feel that when I write a sequence as x1, x2, dot dot dot, xn, what I am essentially doing is I am actually writing the range of the sequence. Okay. Now, please understand, when you write a range of the sequence, then if there is a number, a value which is repeated, means for example, this sequence xn equal to minus 1 by n. So when n is 1, it is minus 1. When n is 2, it is plus 1. When n is 3, it is again minus 1. So if this value is repeated, then the range of this function fn equal to minus 1 by n, here it is a real number, then it is just minus 1 and plus 1. But when we write the sequence, we are writing minus 1 plus 1 minus 1 plus 1 so on, and not as minus 1 plus 1. So what x1, x2, xn is telling you, it is actually describing, it is giving a complete description of the function. X equal to 1, what is the value of y? That is, what is the value? Y equal to f of n, what is the value of that y? That is x1. X equal to n equal to 2, what is the value of the f of 2? That is x2. So it completely describes the function. So this x1, x2, xn actually represents the function and hence represents the sequence. That is a key fact that you have to understand, that this representation of x1, x2, xn actually represents a function. It does not represent the range of the function. So basically what it does a complete description. It tells you when n equal to 1, when the input is 1, then what is the output? It is x1. When the input is 2, the output is x2, and so on. This is something you have to understand and keep in mind. So just like a notion of a subset of a set, you have the idea of a subsequence. Subsequence has to be taken carefully and written carefully. So if xn is the original sequence, then subsequence doesn't have all the elements that occurs in the sequence. It essentially takes a subset of the sequence, if you want to think like that. It doesn't take everything. So that is a new sequence that you form out of the old sequence. So when you form a new sequence, it has a different indexing number. So n, actually the input, we call that is an index. When you write the sequence as x of n here, This n is called the index, and this index is very important. So xn is the first sequence, and from that you have created a new sequence, so it will have a new indexing, and that is indexed by k. So subsequence is denoted by xnk. So it is xn is the original sequence and k is the index of the new sequence. Because for example, I have the sequence 1 2 3 4 5 6 itself, n itself, so it's identity sequence, and then I form a new sequence which is the sequence of even numbers 2 4 6 8 and so on. Now what is happening is, now what is xn? So xn is the, say, 1 2 3 4 5 6 7 8, x1 is 1, x2 is 2, and so on. So now the new sequence is the sequence of even numbers xnk. So xn, sequence is xn, and now you take the first point of the subsequence, first element. xn1 is 2, xn2 is 4, xn3 is 6, and one has to understand n1 here represents x2. So n1, that n1 actually indicates xn1 actually is x2. The first element of the subsequence is the second element of the sequence. Now it's very important, the sequence has an order. So how do I write the function? I first put n equal to 1, see what is x1, then I put n equal to 2. So I keep on increasing the value of the numbers from 1, 2, 3, 4, 5, 6, and I go on. Now when you take a new sequence, when you create a new sequence out of an old sequence, this ordering of increasing, you increase the index value as you go on, that has to be maintained. So if k is strictly less than j, then n of k must be strictly less than n of j. This is something which is of key importance, that the ordering has to be maintained, right? So for example, look at the sequence 1 by n, xn equal to 1 by n, real sequence. So is 1 half, 1/3, 1/4. So n is equal to 1, I'll get 1. N is equal to 2, I'll get half. N is equal to 3, I'll get 1/3. N equal to 4, I'll get 1/4, and so on. Now suppose I am creating a sequence, I am taking only the sequence, the subsequence as a new sequence whose outputs are corresponding to the even values. So xn1 here is actually x2, it's half. xn2 is 1/4. So here for k equal to 1, we have nk equal to 2, that is x2. Then that is xn1 is equal to x2. So n1 equal to 2. Now you see, look at what is 1/4. It was here. Here it is n2. But what is n2 here? N2 there is 4. Is a n2 is actually, sorry, xn2 is actually x4 of the original sequence. So n2 is actually 4. So when 1, when k1 is strictly less than 2, when k equal to 2, then n2 was 2, and when k equal to 2, when k equal to 1, n1 was 2, and n2, when k equal to n2 was 4. So this is maintained, this ordering has to be maintained. You cannot write a sequence like 1/4, 1/6, half, 1/8, and then you write some 100 and then you write 110. Not like that. You cannot be haphazard. This order has to be maintained. So if I am increasing the value of the index of the subsequence, then whatever sequence element that you have chosen at the kth place, and if you go to some j which is strictly bigger than k, then the value, then the element of the sequence that should enter in the jth place must have an index in the original sequence which is higher than the one which has entered in the kth place, and that has to be maintained. See, please understand that if I continue talking about a subsequence, one has to understand that, for example, if I written it like this 1 6 1 4 half 1 8, then this cannot be a subsequence. We will not consider it as a subsequence, because here this thing is broken. Here n1, here if I look at n1 is what? n1 is 6. Well, here the first element of the subsequence is the sixth element of the, and the second element of the subsequence is the fourth element of the sixth element of the fourth element of the second element of the subsequence is the fourth element of the original sequence. So what has happened? We have broken this. So when k is strictly less than j, nk must be strictly less than nj, right? Means the sequence number that you have chosen from there. So here n1 is 6 and while n2 is 4. So that sort of thing would not happen. So I hope you have a idea about what is a sequence and a subsequence. We end this discussion here, and we will then talk about the notion of a convergence of a sequence in our next lecture. Thank you.